Hey everybody, welcome to Soil Basics. I'm going to run through this quickly. Please make sure that you take notes on the PowerPoint and put it into your binder or notebook. So just some basics here. Here we go. So we have a lot of benefits of a healthy soil. So first of all, we can sustain life, right? So habitat. We've got a lot of microorganisms that live within the soil, and they can help to keep pathogens in check. We have animals that burrow, which help with aeration. And so it provides a habitat for microorganisms, both macro and microscopic. We've got water storage. So good soil, remember it holds water and allows it to move. So with good soil, we want it to drain, but we don't want it to dry out too quickly. And then in addition to that, we've got nutrient storage. So this is where we're getting vitamins and minerals that are being uptaken by the plants that live in the soil with their roots. And obviously, the nutrients, when we talk about vitamins and minerals, are atoms, and those atoms are stored within the soil. And remember that the three main ingredients that we want to have are nitrogen, phosphorus, and potassium. So NPK storage. Okay, moving on to different soil types. Here's a floodplain in the upper left-hand corner. Floodplains, they have soil that's deep and fertile. We've got silt that's carried during floods onto the soil. It's deposited in these floodplains, and the soil then has a really good texture, a really good mixture of sand, silt, and clay. A lot of times we have like unconsolidated sediments, often extending if in the stream far below. This all gets washed on, and so it creates a really good texture and then really good fertile land to use for agriculture. In the upper right, we've got tropical rainforest here. If you look at the cross section, it really just looks red, right? And hopefully you notice here that we don't see any roots. Like, where are all the roots? It's weird. But with tropical rainforest, we have really shallow, low nutrient levels, really just like within the first few inches of the soil. And a lot of people, there's a misconception out there that the soil of the rainforest is very productive, right? We've got a lot of slash and burn happening, which creates some nutrients in the soil, but that's short term. In reality, the green, the foliage, we have soil, canopy soil that's up in this canopy. All of the nutrients, not all, but a lot of the nutrients are held up in the top in the canopy of rainforest, not necessarily in the soil. A lot of the root systems are outside of the ground. We've got a lot of epiphytes, which are plants that have live on trees, and the roots are just chilling out in the air, and so they're getting a lot of their nutrients from the air and from, once again, also the canopy soil. When we talk about the soil here in the rainforest, a lot of the root systems, once again, are outside of the ground. The water moves through the soil very, very easily, and it really washes a lot of the nutrients away. So what we have left are insoluble, right? Insoluble atoms like aluminum and iron, right? A lot of aluminum is left over. Water carries all of our dissolved minerals, our dissolved ions that have the ability to dissolve away, right? Leaving insoluble materials. And one of the main atoms that's left over is aluminum, because it does not dissolve in water. And therefore, we'll see in a subsequent slide that we mine for aluminum in our tropical rainforest areas. Okay, if we look here, when we talk about our soil horizons, which we're going to see later on in the PowerPoint, we don't see a lot of horizons here, right? The soil horizons are quickly depleted of nutrients when the soil is removed, and once again, we'll see that. Here in Colorado, we're familiar with mountainsides because of the landscape, right? We have easy erosion or movement of the soil happening, and therefore the soil gets easily depleted on these mountainsides. So with our soil types, right, we have deep fertile soils, our floodplains, lots of organic matter and nutrients. We have shallow nutrient soils like our rainforest that has low organic matter. And then we have easily depleted soils where the forest is removed, our mountainsides, you can see here a cross section of soil. So at the top, we've got topsoil. The subsoil is a sandy clay, right? That's particle size, which gives texture. And then we've got that weathered parent material underneath. If we look at the root systems of our rainforest, though, this is super interesting. Here's a cool picture of different root systems. We do have a lot of shallow root systems because of the nutrients sitting at that top layer. The nutrients are in the humus. Oh, did I say hummus? I must be hungry. Humus. And it's that very top layer of topsoil where we have this. Most of the nutrients are in the canopy. This is why we have such green growth and it looks beautiful, but a lot of the roots are above the ground. We also have a lot of epiphytes, which have their roots in the air. Let me click here. So these are some epiphytes living on trees. Their roots would be in the air. We have a rapid rate of photosynthesis happening, right? A rapid rate of photosynthesis is taking place. And so this is another reason why the soil doesn't have a lot of nutrients, because it's all of the plants, any nutrients that are there are going to be taken up pretty quickly by these plants. The plants do create some type of canopy soil. So there's soil up in the canopy here, which is also pretty cool. Our boulder soil, when we talk about the boulder soil or soil in general, soil is made due to climate, the geography, and the geology of the area. And so here in Boulder, you can take a look using this URL. But typically our boulder soil, we have really thick clay. It lacks organic material. And so because we have this thick clay and not a lot of organics mixed in, it impedes our drainage. So we don't have a lot of good drainage and root growth. Obviously, it's hard to grow, right? Whether that's our grass or food here, just because of the texture soil or the soil's texture. We do have a state soil. It's the SEAT soil. This was established around 1972, and you can actually look that up. But we do have a state soil if you're interested in that, which is pretty cool. Here are soil horizons, which we talked about briefly in class. This is how you this is a way to analyze, right? We can see here the layers present in the soil, whether they have them or not. O stands for our organic matter. The humus and the litter. The humus is just organic decomposed plants by microorganisms. The litter are dead plants that are chilling out there. And our organic matter, this is our topsoil, right? This has the greatest amount of organic matter in it, this O horizon. Then under that, we have A, which is our surface soil, where we have our microbes and plant roots and some more humus. Under the subsoil, no humus. And then our C horizon is our parent rock, and our R is our bedrock. And there is bedrock. We see that a lot here. If you go out east, though, a lot of, a lot of the layering, we just have soil. We don't see a lot of exposed bedrock out east, depending on how close to the coastline you are. Now, our A horizon is our zone of leaching, where water is moving through and leaching out or taking out our dissolved minerals and our atoms, really, our dissolved atoms. And then B is where we have accumulation happening. And we're going to see that on the next slide here. This is a vineyard in Massachusetts. And kind of what's striking is this really white layer underneath the topsoil. This zone of leaching, you can see, is really low in iron. Iron dissolves and gets moved down to the second layer. It's the iron-rich layer here, and it's kind of hard to tell like what is going on as far as the layers. What we do see, though, is that the layers above, right, the zone of leaching, really, it's a finer type texture, right? That means the grains are a lot smaller, right? So we have small particles, and then we move on to larger particles as we move down into this bed. Heavy rains can cause what we call hanging. And so that's what they think has happened here is when you get a lot of water, it hangs. And then when you get enough of it, it will flush down into the second layer and leach down. So we're kind of like devoid of iron, perhaps. Okay, So weathering. Soil is made from weathering. This is our plant material. Weathering is caused by chemical, biological, or mechanical weathering. So if it's chemical, think about limestone or calcite that's being degraded by acid in the rain that falls. If it's biological, moss or lichens will come down in primary succession. They kind of come in first to bedrock and start to break down rock. And then mechanical. So if we have rocks and plant roots in them, we can get root wedging. We can also get, if there's cracks in rocks, ice wedging, where ice will get in there and it will freeze and thaw and it will expand just like the roots will, and it will slowly weather the parent material. Okay, iron and aluminum rich soil, right? It says heavy rainfall, leaching. We typically see a lot of iron and aluminum in tropical regions. A lot of aluminum. And so when we talk about leaching, remember leaching is just loss of water soluble nutrients, right? So anything that is water soluble dissolves in the water and then leaches. It moves with the water out of a particular horizon or area of the soil. And this can be due to rain, but it can also be due to over irrigation or just irrigating like our fields, right? Even our lawns. And this is why we have to fertilize our lawns. Lateralite is a type of soil. Lateralite is rich in iron and aluminum, and this is formed in hot, wet tropical regions. And there are names for different types of soils that we typically find in different regions. Lateralite, once again, hot, wet climates, typically tropical, and they typically have, oh, excuse me, high amounts of insoluble metals, so that iron, or excuse me, aluminum. And this is why, if we go to the next page, what we're going to see is miners, right, taking off topsoil to extract the ore. They're typically mining bauxite. Bauxite is an aluminum ore, and we take the bauxite out, and we then separate the aluminum, and then you have an aluminum can. This picture right here is why you should always recycle every piece of aluminum that you can in every can. This is super destructive, obviously, to the forest itself. This mining, you get a lot of nutrient loss occurring really quickly when the forest is removed. So once again, a lot of nutrient loss occurs quickly when they just take off and mine or take off the forest so they can mine for this bauxite. So mining, this is an issue when it comes to deforestation. The deforestation then is leading to biodiversity loss when it comes to plants, animals in the tropical regions. Okay, so soil is the interface of spheres. So we have an interface of the hydrosphere, which is water, lithosphere, which is the land, biosphere, right? Some interesting statistics about our soil. We know that the soil provides ecological services such as benefits. The economic benefit of soil is about $17 trillion a year. The biological, the nitrogen fixation, nitrogen is once again one of our macronutrients that soil needs, is about, they quantify it as $50 billion a year when it comes to soil. So, and food production, once again. So soil is a system. It interacts with other systems here on planet Earth. And super important as it takes hundreds of years for that soil to reform. Okay, I'm not going to go through these, but you can try to sketch a soil system yourself using the system notes yesterday. There are some other sketches here so you can kind of see how that was done, but maybe try to sketch a soil system on your own right now using the notes from yesterday and see how you do. We can talk about your picture and what you have tomorrow. Thanks, guys.